And then I know that Dylan Storey likes nothing better than a good old banging house track to get him in the mood for staring into space. And Dylan Storey joins us this morning. Morning, Dylan.
Morning, Wemo.
Yeah, I saw you, hand in the air there, raising it up.
Yeah, you know me. You know me too well. I can't resist.
I know. Let's stare into space. First up, another satellite could be screaming towards Earth and could be headed to your house.
Yeah, well, we talked about, it must have been only a few weeks ago, about the NASA satellite that was plunging down to Earth in an uncontrolled descent, meaning it could basically land anywhere. And so there's another one happening, and it's predicted to land on Earth on October the 22nd or the 23rd. And so this is a German satellite called ROSAT, standing for something, it stands for Röntgen satellite, whatever that means. And it doesn't have a propulsion system on board, so they basically can't control when it descends. So it's completely at the mercy of when the forces of deceleration caused by the particles of atmosphere up in near space there, when they happen to slow it down enough so that its velocity causes it to descend back into Earth. So they based on its sort of trajectory, they're predicting this window between October 22nd and 23rd, but that's a pretty inexact science. So
are they not aware that there's an All Blacks game on the 23rd?
Well, I mean, I can't believe they didn't plan for that when they originally launched the satellite.
Yeah.
However, many years ago they did launch it.
Absolutely crazy.
Yeah. So it was a big overlooked fact. But it will again break into pieces as it comes down through the atmosphere, but not enough pieces to make it harmless. So they're saying it's going to crash into the Pacific Ocean somewhere, probably. But if there's going to be a plus or minus 5 hour exact time once its descent starts getting mapped. So when you sort of see, there's a nice video on the internet actually of how it orbits diagonally across the Earth, and because the Earth turns, every diagonal orbit is going to be over a different place.
Right.
So 5 hours can take it through vastly different areas of the planet. You know, it can take it literally from one side of the planet to the other. So that's quite a big margin for error and for guess.
I mean, that satellite that came down a few weeks ago, on the scale of things, ended up coming pretty close to New Zealand. Yeah.
I mean, another few minutes in the air could have been in New Zealand's vicinity.
It came down, but somewhere between New Zealand and Papua New Guinea, right?
Yeah, somewhere in the Southwest Pacific there.
Yeah.
Southeast Pacific. Yeah.
And just looking at the diagram, looking at the video of where it's headed, it actually does go over New Zealand at least a couple of times.
Yeah. Well, it will go over everywhere. Because it's sort of systematically going diagonally, so the Earth turns, it basically goes over every spot of the Earth apart from the poles. But so there's they've kind of got a rough estimate of it'll slow down this much by this time, so it will probably fall in on this group of 10 laps of the Earth. But 10 laps of the Earth is huge. And there are some parts of it that will probably survive re-entry and hit the ground in one piece, such as a 400-kilogram mirror. Right. So if that landed on your head, you wouldn't be too happy.
No. Okay, all right, we'll look out for that in the night sky this weekend. Something else, though, that is interesting and popped up on the nets this morning is a video released by NASA that shows the new rover technology, Mars rover technology.
Yeah, I haven't seen it yet, unfortunately. But I have seen a lot of the planning stages of the Mars Curiosity rover.
Yeah.
And so, from what I understand, it's designed to combine the best parts of the two previous rovers. So, the Mars rovers, as they're known, Spirit and Opportunity, they've got wheels and they can drive around, meaning they can get to different places, they can look at different things. they've got a drill, but they're not actually equipped to dig down under the surface.
Right.
And so after that, NASA landed the Phoenix probe on Mars's poles, which was static. It just landed. It didn't have wheels. It couldn't move around. But it could dig down, and that was very important for finding the presence of water, and it did confirm the presence of water. So Curiosity is much bigger, or Mars Science Observatory, as it's also called.
Yeah.
It's much bigger and it combines both. So it's like the moving robot. It's got the little camera up the top. It can move around, but it can also dig down below the soil. So it's designed specifically to look for signs of life in the past on Mars.
And it will also be more powerful, being bigger, I guess, as well, and also use its power more wisely. The technology is coming forward.
Well, the very fact that it's bigger is very significant because it can get over so many more rocks and obstacles. So the Mars rover, the previous rovers have done a fantastic job, but they've been controlled very carefully to get around every little object. Whereas so this Curiosity is going to be a lot more stable, going to have a lot wider wheelbase, and of course it's going to be equipped with a much more sophisticated level of scientific analysis instruments. So it's quite cool how these things work. They've got these little arms, and they reach out and they pick things up, and then they bring them back in, and they tip them into little analyzing machines on the body,
like a mini laboratory.
Yeah, like a exactly. And then they analyze them and send them back. So there's two parts of the Mars Science Observatory. So one part stays in orbit, whereas then there's the lander that lands. So the lander sends all its information up to the orbiter, which then relays them onto Earth.
Oh, cool.
So, I mean, just to put what it's trying to do in some kind of context, Mars is a barren desert covered in iron oxide, which is rust. But there are signs on Mars that probably once, there was flowing water. So, if there was flowing water, the temperature must have been hotter, would have exactly the same conditions that we have on Earth that allow for life. So, it's looking for the possibility that life ever existed. But it's very difficult because when we collect fossil samples or samples of life on Earth, we're usually looking at tens, or from hundreds of thousands to tens of millions of years ago.
Yeah.
But Mars life wouldn't be for a few billion years. So it's looking much further into the past than most archaeological searches on Earth are. So it's very, very difficult. That's the point. It would be, even if we were there, it would be very difficult. It would be a big scientific effort to try and discover signs of this previous life. But also the remoteness factor makes it much, much harder. So it really is looking a long way back into the past and trying to discover what was going on.
Yeah, without actually being there. It's pretty amazing. Well, I'm back here on Earth, though. Where can we, what can we see that's interesting in the night sky right now?
Well, Jupiter is the big feature of the night sky at the moment. It's very bright in the east, risen above the horizon. Looking at it through the Stardome telescopes the other night, you could see all four of its Galilean moons around it. So it's four big moons. They appear as four sort of small dots in a line, either to one side or to both sides of the planet. On a good night through the Stardome telescopes, you can see the cloud bands. So you can see the different those different stripes of colour across the planet.
Cool.
So, yeah, Mars is worth having a look at through a telescope.
All right, cool. And we do that, of course, at the Auckland Stardome Observatory, this place. And you can also continue the conversation, perhaps ask Dylan Storey more questions on Twitter, twitter.com/Dylan Storey. Thanks very much, Dylan.
Thank you, Emma.
It's now 7.